Hello, and welcome to our exhaustive guide on JavaScript data types. Whether you're a beginner or preparing for a technical interview, understanding how JavaScript handles data is fundamental. Over the next few minutes, we'll dive deep into primitives, objects, and crucial concepts beyond, giving you all the tools to master this topic for any interview. Let's begin by defining what a data type actually is. So, what exactly is a data type? Simply put, a data type is a classification that specifies the type of value a variable can hold. This is crucial because JavaScript is a dynamically typed and weakly typed language. This means that data types are determined at runtime, not when you initially declare a variable, and it allows for implicit type conversions. This flexibility is great, but also requires a clear understanding of how different types behave. Let's start exploring JavaScript's primitive data types. JavaScript divides its data types into two main categories, primitives and objects. We'll start with primitive data types. These are the fundamental building blocks of JavaScript, representing single, simple values. There are 7 primitive types. We have string for text, number for both integers and floating point values, Boolean for true.false logic, and null for the intentional absence of any object value, undefined for unassigned variables, and symbol, introduced in ES6, for unique identifiers. Finally, big int, added in ES 2020, handles arbitrarily large integers. The key feature defining all primitives is their immutability. This means once a primitive value is created, it cannot be changed. Any operation that seems to change a primitive actually creates a new primitive value. We'll explore each of these in detail, starting with string. Our first primitive type is string. A string represents a sequence of characters, essentially text. You can define strings using double quotes, single quotes, or backticks for template literals, which allow for embedded expressions and multi-line strings. Here, first name is Alice, using double quotes. Message uses single quotes. And greeting uses template literals, a useful ES6 feature. Checking type of first name confirms it's a string. Remember, strings are immutable. Any method that seems to modify a string, like toUpperCase, actually returns a new string. Next up, the number type. The number type represents both integer and floating point numbers. You can declare numbers as simple integers, like age being 30, or floating point values like price at 19.99. JavaScript's number type has a specific range. For very large or very small numbers, you can use number.maxValue or number.minValue respectively. Here, big number shows a large number, and small number a small one. Beyond standard numbers, there are also special numeric values. Infinity and negative infinity represent mathematical infinities, often resulting from operations like division by 0. And then there's nan, or not a number, which indicates an undefined or unrepresentable mathematical operation. Checking type of age confirms its type as a number, and 0 divided by 0 indeed results in nan. Remember, even though numbers can be positive, negative, integers, or floats, they are all ultimately of the number primitive type and are immutable. Next, the Boolean type. A Boolean represents a logical entity with only 2 possible values, true or false. They are fundamental for control flow in programming. You can declare a Boolean directly, like isLoggedIn being true. Booleans also result from logical operations and comparisons. For example, age greater than 18 is true. Checking type of isLoggedIn confirms it's a Boolean, and 5 strictly equals 5 is, of course, true. Remember, Booleans, like all primitives, are immutable and crucial for decision-making in your code. Next, we have undefined. Undefined is a primitive value automatically assigned to variables that have been declared but not yet initialized. It also indicates the absence of a value, such as a missing function parameter or a non-existent object property. If you declare my variable without assigning a value, it defaults to undefined. Accessing a non-existent property like user email on an object also yields undefined. Functions that don't explicitly return a value will also return undefined by default. Checking type of my variable correctly returns undefined, and logging result from our function confirms it's undefined. Keep in mind, undefined signifies that a value is not present at all, distinguishing it from null, which indicates an intentional absence. Following undefined, we have null. Null is a primitive value representing the intentional absence of any object value. It's a deliberately assigned value, unlike undefined. You explicitly assign null when you want a variable to clearly indicate no value. A common use is to reset an object variable or to indicate a function parameter that received no object. Now, the famous JavaScript quirk, type of null. Despite null being a primitive, type of null returns object. This is a long-standing historical bug in JavaScript that cannot be fixed due to backward compatibility. Be aware of it, especially in interviews. Remember, null means intentionally empty, while undefined means not yet assigned or missing. Next, we have symbol, a unique primitive type introduced in ES6. A symbol represents a unique and immutable value. Every time you create a symbol, it's guaranteed to be distinct from all other symbols, even if they have the same description. This uniqueness makes them perfect for creating private object properties or avoiding naming collisions. For example, we can use a symbol as a unique key in an object, ensuring it won't clash with other string-based keys. You create a symbol using the symbol constructor, optionally providing a description for debugging. Notice that even if we create another symbol with the same description, id2, they are not strictly equal. This proves their inherent uniqueness, and type of confirms it's a symbol. Symbols are powerful for metaprogramming and avoiding unexpected property name clashes in larger code bases. Our last primitive type is BigInt, introduced in ES 2020. BigInt is a numeric primitive that can represent integers with arbitrary precision, meaning they can store numbers larger than JavaScript's standard number type can safely handle. You create a BigInt by appending n to the end of an integer literal, or by calling the BigInt constructor. Here, large number is a BigInt created with the n suffix, and another BigInt uses the BigInt constructor from a regular number. Checking the type of large number confirms it's a BigInt. A key rule for BigInts is that they cannot be mixed with regular numbers in operations without explicit conversion. Adding a regular one to large number would cause an error. You must add another BigInt, like 1n. BigInts are crucial when dealing with very large IDs, timestamps, or cryptographic values where precision is paramount. Having explored all 7 primitive types, let's now turn our attention to the second main category, the object type. Unlike primitives, which store single values, an object is a complex, non-primitive data type. It stores collections of data and more complex entities, essentially acting as a container for properties, each consisting of a key and a value. Importantly, property keys can be strings or symbols. The key features distinguishing objects from primitives are that they are mutable. Their values can be changed after creation, and they are passed by reference. This means when you modify an object, you're changing the original object itself, and copies only hold a reference to that same object in memory. Here's a basic object person with properties like name and age. We can easily add a new property, like city, or modify an existing one, for example, changing age to 31. Logging the person object shows these changes. The object itself was mutated, and checking type of person indeed confirms it's an object. Beyond plain objects, many other built-in JavaScript structures like arrays and functions are also special kinds of objects. We'll explore this next. Expanding on the object type, it's crucial to understand that in JavaScript, arrays and functions are also objects. This might seem counterintuitive at first, as they have their own unique behaviors and syntaxes. However, they inherit properties and methods from the object prototype, demonstrating their underlying nature. Let's look at an array fruits. It behaves like an object, allowing property assignment like fruits type, and type of fruits confirms it's an object. Functions, too, are objects. Our greet function can have a property, greet version, while type of greet returns function, which is a special distinct classification for functions. Remember, they are still objects underneath, inheriting object properties and methods. This characteristic is fundamental for understanding concepts like prototypal inheritance and how methods are available on arrays and functions. It also explains why they behave as mutable and are passed by reference, just like other objects. Now that we've covered all data types, it's time to tackle one of the most crucial concepts in JavaScript: pass by value versus pass by reference. Understanding this distinction is key to predicting how your variables behave when assigned or passed into functions. Let's start with primitives, which operate on a pass by value mechanism. This means that when you assign one primitive variable to another, you're literally creating a completely independent copy of that value in memory. We declare let A and assign it 10, then let B takes the value of A. Notice B now has its own copy of 10. So, if we change B by to 20, you'll see it remains 10, while B is 20. They are completely independent. Now, let's explore objects, which are handled by pass by reference. Here, instead of copying the actual object, JavaScript copies a reference, a pointer to the object's location in memory. We create obj1 with a value of 10. Then, obj2 is assigned obj1. Notice obj2 now points to the exact same object as obj1. Because both variables point to the same location, if we modify a property through obj2, you'll see obj1 value also reflects the change to 20. And naturally, obj2 value is also 20. This distinction is paramount when passing objects to functions, as changes made inside the function will affect the original object outside, which is not the case with primitive values. Before our final takeaways, let's address a common point of confusion: primitive wrapper objects. We learned that primitives are simple, immutable values, while objects are complex. So, how can we call methods on a primitive, like hello, to or uppercase? This is where JavaScript's clever mechanism comes in. When you attempt to access a property or call a method on a primitive value, JavaScript temporarily converts that primitive into a corresponding wrapper object. For example, a string becomes a string object, a number becomes a number object, and a Boolean becomes a Boolean object. This temporary wrapper object then provides access to the methods defined on its prototype, like to uppercase for strings. After the method call, this temporary object is immediately discarded. This ensures primitives remain immutable, while still giving them object-like functionality. You can see its temporary nature here. If we try to assign a property directly to a primitive like myString property equals value, it won't persist. But calling myString to uppercase works perfectly. This is a key concept that bridges the gap between primitive simplicity and object functionality. We've covered a lot of ground today. To quickly recap and provide a useful reference, let's go over the key takeaways from our guide on JavaScript data types. First, JavaScript has 8 data types. 7 of these are primitives: string, number, Boolean, undefined, null, symbol, and big int. And there's one all-encompassing object type, which includes arrays, functions, and more. A crucial distinction: primitives are immutable and passed by value, while objects are mutable and passed by reference. We also learned about primitive wrapper objects, which temporarily turn primitives into objects to allow method calls. Finally, some special notes that are important for deeper understanding and common interview topics. Remember, type of null unexpectedly returns object, a historical bug. Type of an array, like square brackets, will also return object. And type of for functions gives function, despite them being objects. Lastly, big int values always end with an n suffix. By remembering these points, you'll have a strong grasp of JavaScript's data types. Let's move to our final advice. As we conclude our guide on JavaScript data types, here are some interview tips and next steps to help you succeed. First, when discussing data types, don't just list them. Instead, explain the why and how behind each type. Second, provide examples by showing concise code snippets. This demonstrates practical application. Third, highlight key differences, especially between primitives versus objects, and their behavior regarding mutability and passing. Fourth, definitely mention the quirks, like type of null returning object. This shows a deeper understanding. And finally, show practical application. Explain how data types influence code behavior. By following these tips, you'll not only answer questions correctly, but also impress interviewers with your depth of knowledge and practical insight. Keep practicing, keep building, and continue exploring JavaScript. Thank you for joining this guide.